Okay, perfect. In this lesson, we'll continue to explore how Monte Carlo simulations can be applied in practice. In particular, we will see how we can run a simulation when trying to predict the future stock price of a company. There is a group of libraries and modules that can be imported when carrying out this task, but the good news is you have already used all of them. Besides the classical NumPy and Pandas, we will need Norm from SciPy and some specific Matplotlib features. Once again, the company we will use for our analysis will be P&G. The time frame under consideration reflects the past 10 years, starting from January 1st, 2007. We want to forecast P&G's future stock price in this exercise. So, the first thing we'll do is estimate its historical log returns. There is a second way to obtain simple or logarithmic returns, and we will discuss it in more detail in the notebook document attached to this video. The method we'll apply here is called %change, and you must write %_change, open and close parentheses, to obtain the simple returns from a provided dataset. We can create the formula for log returns by using NumPy's log and then type 1 plus the simple returns extracted from our data. And here's a table with P&G's log returns. Awesome! In the first graph, we can see P&G's price, which has been gradually growing during the past decade. In the second one, we plot the log returns, not the price, of P&G. The picture tells us the returns are normally distributed and have a stable mean. Great! Now, let's explore their mean and variance, as we will need them for the calculation of the Brownian motion we talked about in our previous lecture. Remember? We already know how to calculate mean and variance, don't we? After a few lines of code, we obtain these numbers. So, what are we going to do with them? First, I'll compute the drift component we studied in our previous lecture. It is the best approximation of future rates of return of the stock. The formula to use here will be U, which equals the average log return minus half its variance. All right. We obtained a tiny number, and that need not scare you, because we'll do this entire exercise without annualizing our indicators. Why? Because we will try to predict P&G's daily stock price. Good. Next, we will create a variable called stdev, and we will assign to it the standard deviation of log returns. We said the Brownian motion comprises the son of the drift and standard deviation adjusted by e to the power of r. So, we will use this block in the second part of the expression. Okay, we've set up the first Brownian motion element in our simulation. In the next lesson, we will create the second component, and we'll show you how this would allow us to run a simulation about a firm's future stock price.